Hello everyone, welcome to my presentation. Today I'm pleased to present our recent work entitled CSDN CDN-Aware QoE Optimization in SDN-Assisted HTTP Adaptive Video Streaming. The agenda of my presentation includes introduction, state-of-the-art motivation example. Then I will present the proposed solution, following evaluation setup, experimental result, and finally I will conclude the presentation and talk about some possible direction for future work. As you know, video traffic has become the dominant traffic over internet, and it is expected to reach more than 82% of all internet traffic in 2021. HTTP adaptive streaming has been considered as a de facto video delivery technology over the internet. In this technology, video player adapt the video quality by considering client resources like playout buffer and network conditions. The adaptation process can be performed with different schemes. One of them called pure client based, with insufficient information about the network by just considering buffer status or local parameters. So it seems it can lead to suboptimal adaptation decision. For remedy this problem, network assisted approach are proposed. The decision is performed via a centralized component with a global view of the entire network topology. So it can be more beneficial for the user's QE compared to the first approach. Fundamental networking paradigm like softwareization, virtualization, edge component, fog component, computing have been used in modern network assisted framework. One of them called software defined network or SDN. In SDN, data plane and control plane are decoupled from each other, and control plane is placed in a SDN controller as a hard part of this network. So some traditional network problem like complex network devices management overhead or limited scalability could be solved by this approach. As another promising technology, NFV or network function virtualization is introduced. In this technology, virtual network function like a virtualized router, firewall, or virtualized load balancer um, is utilized instead of traditional vendor-based router, firewall, etc., etc. So they can accelerate uh, innovation for designing the network. In our previous network assisted approach called ESHAS, we designed this architecture. The novelty of ESHAS was introducing virtual reverse proxy that used the NFV technology at the edge of the network. Each virtual reverse proxy tries to collect some information from client side, cache occupancy from CDN side, and available bandwidth from SDN controller, run an optimization model to decide about best place for fetching the requested quality. Specifically during the cache miss, we use a novelty called replacement quality as a better quality instead of fetching from the cache server. But let's talk about our motivation for CSDN. What happened during cache miss for pure client-based systems? We should just fetch the requested quality from origin server. But imagine the requested segment are unavailable in any cache servers, and the replacement quality as a better quality is not acceptable from the client. Again, we should fetch from the origin server. We encounter some phenomenon like negative phenomenon like the buffering, also wasting the backhaul bandwidth. So we propose CSDN to remedy this problem. CSDN equips the ESHAS virtual reverse proxy with transcoding capability. At the edge of the network, we have computational cost for this time-consuming transcoding process, but we could improve backhaul bandwidth consumption, also the user's QoE. So we have fetch-based action and transcoding action at the edge of the network of CSDN. We propose this architecture for CSDN with this design equipped virtual reverse proxy. You can find more information in the paper. Again, we use the time slot like ES has for collecting the data and running our optimization model. The objective function of server segment selection policy of CSDN is minimizing the serving time, including the transcoding time, also the fetching time, and minimizing the deviation as advantages of ES has system. For the evaluation, we design our testbed, including 100 clients in a real-world cloud-based environment, and compare performance of ES has with performance of CSDN with ES has a Savior and pure client-based approaches. As you can see in these figures, we could improve not only users QoE, I mean the playback bitrate, the number of quality switches, the number of stalls, but also we could improve network utilization in terms of number of fetches from origin servers and bandwidth usage. You can find the reason behind this improvement in the paper. As a conclusion, we leverage SDN, NFV, and some networking paradigm, and we design a network-assisted video streaming. We implement our approach in a real-world environment, and the results show we could improve the performance of state-of-the-art edge caching. Extending proposed MILP are considered as our future book. Thank you for your attention. Feel free to ask your